Hello, my name is Alexei and I'm representing the company Qaprosoft, and the topic for my speech is Dockerization of a real mobile device farm, how Docker generally helps us to scale up the infrastructure for QA automation. Today I would like to share our experience in deploying of such a cloud and to share a few of our open source products. Main topics will be practicability of creating a private mobile cloud, components we use for our clouds, how Docker helps us to deploy the infrastructure and maintain it in the future, how we generally scale and deploy for web automation with the help of wonderful open source products provided by the guys from Aerocube, such as Selenoid and Router. At the end of my speech, I would share a little bit about using Docker Compose for orchestration of the components of the infrastructure. First of all, while deploying a mobile cloud, you have to understand that you have a significant amount of tests running on a daily basis. I think many of you have integrated a certain CI process in automation. Tests start running after the development build or according to a certain schedule in CI. In our case, we run about 1,000 plus mobile tests. Some customers have even more, and results are needed as soon as possible. Who has an experience using Appium test automation? Please raise your hands. Nice. I think many of you have faced the problem of fragmentation on Android devices. Often tests are written for one version of Android and you have to adapt them to optimize them for different form factors of devices, for different versions of Android. It's a pressing problem. In our case, we would like to use cloud for automation manual QA engineers. We had such a task. Many of our customers place highly strict requirements for security, so that was one of the key moments why we switched from public services to deploying private clouds. And all in all, since one of our major customers is a fitness brand owning several fitness apps, we had to test its integration with the IoT devices. Different fitness bracelets, smart sneakers, heartbeat monitors, and so on. So with the help of some external services offering mobile clouds, it's quite hard to do that. You would say, there are many such solutions on the market offering you both emulators and real devices. I think many of you have heard about Browser Stack, Sauce Labs, Amazon. In my view, there are both positive and negative sides of using these solutions. First of all, if you don't have many tests and you don't often run them, then you'll get a much more cost-efficient price, because in order to deploy this infrastructure, you have to buy servers, mobile devices, which you have to administer, change components, or all in all update this cloud. Of course, all the services provide a wide range of devices with different Android versions and a variety of form factors. In this case, private mobile clouds are losing to those advantages. But at the same time, there are some indisputable negative moments with using those services. First of all, while running tests, there is no direct way of debugging those tests for the reason of limited sessions, some resources limited to 10 minutes. It is not always possible to remotely access database server to perform some actions with a device which is not directly accessible through Appium. Also, if you are using a standard pricing plan, you have to wait for device in the queue, and it takes certain time. Security issues are solved non-trivially, and many customers don't want to manage the whitelist of IP addresses which are needed for the external testing service functioning. I want to say a few words about the components of our mobile cloud. Share my experience. We use Android and iOS devices for testing. Key moment for iOS testing is using Mac Mini server. We see it as an optimal combination of price and capacity. It connects up to 5 devices. For connecting to Mac Mini, we use proven by experience USB hubs. The vendor is pluggable. They're cheap and connect up to 7 devices. They have an external power supply, and all mobile devices are constantly being charged and are available in the cloud. It's easier with Android devices. We're using Ubuntu servers with 4-core i7 processors, 32 gigabytes of RAM, SSD drive for better performance, and on these servers we use an additional PCI card, which allows us to connect 4 additional hubs, and 30 devices are running quite well on such server. Another key moment is using quite powerful access point, Ubiquiti Unify equipment. Allows to create a seamless connection by connecting several access points into one cluster. As a result, you get a stable internet connection on all those mobile devices in the mobile farm. Now we're getting to a key point of my speech, Dockerization of a mobile device in the context of a mobile farm. From the previous slide, you've seen that every device is connected to server through the pluggable USB hub. In this case, we're considering a Linux server. I think many of you working on Unix systems, including Ubuntu, have heard about UDEV service, which factually controls USB tire and all events concerning registration and deregistration of all these server-connected USB devices are going through the service. By setting the corresponding URLs, you can run or stop the container. In our case, we have a pre-made device image containing a required minimum of data for device to be registered in a mobile farm. The first is Android SDK, ADB server in particular. The second is Appium. The third is STF client. I'll talk about it a bit later. It's a web interface allowing to control the device remotely and interact with it as if you are holding it in your hand. And the fourth is Java. If you look a bit to the right, there we have 2 more containers, STF, the interface for web control, and a classic Selenium grid. In fact, all of our automation tests, as well as web tests, are going through Selenium grid, which aggregates our devices into one big cluster. Yes, from my experience, this particular configuration of the Linux server easily withstands the load of 30 devices. No, we don't browse the Android Development Studio. In this case, we use minimal set of things like Android tools and ADB server, which allows to interact through Appium and register in the STF service. A small example of UDF URLs. I think some of you may already have worked with those URLs. Briefly, we just create a symlink. Each newly added device has its own serial number, UDID, and we create this line with symlink, which consists of device's UDID, its readable name, in this case we have Motorola G4, and the required range of posts for working with Appium, and OpenSTF, which are later forwarded to the host machine. The ending line says that in case of operation completion, the change of state, addition of a new device to the tire, or disconnection of a device, there is being called a shell script device to Docker, which tries to detect what happened to the device, and if there's a device with such an UDID, it creates a container and registers it in the infrastructure. On the picture, there is a general scheme of Qaprosoft's infrastructure, which is open source. I'll share some links later, and you can try to integrate this approach into your test automation process. A few words about Zafira. This is our tool for aggregating test results. We use Selenium-based framework on Java and register all test results through this web service, then visualize the results with the help of various dashboards configured for your needs. The whole Selenium infrastructure is also Dockerized. Now we've talked a bit about Dockerization of mobile devices, a mobile node. Later I'll talk about our experience in Dockerization of a web structure, Selenium, with the help of IROcube solutions. Infrastructure in the form of Jenkins is also in Docker. Some image of the Jenkins master, which consists of pre-made set of plugins, basic security configuration, a set of job DSLs, which let you create job automations. Jenkins Slave, in its turn, has a required minimum for running the tests. In our case, is Java. Maven, with the help of which we're running test suites, and Android tools for running mobile tests. We have also Dockerized OpenSTF, it's a web application, and Sonar for maintaining the code quality of our automation engineers. Let's talk a bit about the profit, why it is convenient to use Docker, why you don't run Appium directly on a host machine and manually set up a bunch of different ports and sessions. First of all, it's the isolation of ADB server. In my opinion, it wasn't initially implemented for accessibility of 20 or 30 devices on one machine. 2 or 3 or 4 are okay, but it gets problematic. In our case, every container runs its own ADB server and it works with every device in this container in an isolated way. The second reason is the Appium server isolation. I think many of you have experienced issues while running concurrent tests. This issue is solved by isolation in the container itself. Also, it's an automatic start of the container after connecting to a mobile device. You can place a device storage in your office and use those devices. For example, if a manual QA needs a certain device, they take it, device to Docker deregisters it from the cloud, and then registers it back automatically once the device is plugged. Sure, there are some problems once or twice a week, but 99% of the issues are solved by restarting a Docker container. This can be done by an automation engineer as well as a manual QA tester. The code line is running in the terminal, so it's quite easy. Configuration itself. When you have a few Docker images for deploying the infrastructure in Docker Compose YAML, you can set up and scale your cloud just in minutes. Here is me on the picture showing one of our mobile cloud storages. It's a metal cabinet with perforation, several shelves for devices of various form factors, and a server equipment placed on two tiers: UPSs, servers, and some additional stuff. This is the STF interface, or the interface of the OpenSTF web application, which is also open source. All we did was placing it into a Docker container because my experience shows that OpenSTF is deployed in a very non-trivial way. It may seem there's quite a lot of documentation out there, but the running of particular providers, the service itself, proxies, requires a certain perseverance. In our case, everything is ready. You run the building process through Docker Compose YAML, clone the image, and it starts automatically. On the picture we see a set of devices, and on the right there's an interface. In this case it's Samsung S7, a real device in the storage. An image from the device is displayed on your desktop, and with the help of a mouse you can swipe, type, click, even the keyboard is available. You can install APK files through the STF. You can look through the logs, check the battery temperature. There is a lot of useful data. Now I want to smoothly switch from mobile automation to web automation because we build universal solutions and can't go without web tests. Main problems I think many of you have faced while building a Selenium infrastructure are: first of all, you always need to monitor the compatibility of current Chrome driver or IE driver with the current browser version. If the browser has updated automatically, you can quickly break your test automation infrastructure. Of course, HDD and SDD spaces quickly become clogged with temporary files, logs, pictures, screenshots, which is also one of the problems. It's almost impossible to run two separate browser versions on one machine. It can be done, but it's difficult, and there's an alternative to that. Authorization from the box is not supported through Selenium or Selenium Hub, so let's find a solution for this problem. On the Alex conference in Minsk, Belarus, Artem Yeroshenko from Yandex suggested a tool called Selenoid. Folks from Aerocube made a really cool thing. In fact, it's a new implementation of Selenium Hub. The essence of it, you can see it on a GIF. Your test is addressing the hub with the same desired capabilities like you do on a local node or a hub in your infrastructure. If Selenoid detects the configuration is compatible to a desired infrastructure, it sets request to Docker for creating a Docker container for your test. This container will consist of a required minimum: Chrome, Firefox or Opera, Selenium, and when the process is completion, and in the same way performed any actions concerning testing your web app, and when testing is complete, this container will be deleted. What are the main advantages? The first one is certainly a fewer resources are required. Developers claim that it's a fully isolated environment. Every test is run in a separated container, so there are no conflicts. A good solution from the box, Selenoid, lets you see in the real time the WinC session through a browser, how the test is running, log in the Selenium data in the context of one node, and you can record the video and attach it to the test results in order to analyze the issues with automation or the product itself, which I think is a really cool feature. This is how the Selenoid UI looks. There's a nice interface where you can see the utilization of your infrastructure, How many nodes are currently available? How many of them are busy with the process and what browsers are supported? This is the interface of a current running session. You can open it and see in real time how browser VNC client is showing you what's happening in a box, Docker, how the test is running, and all Selenium logs are handy. The guys concerned is the scalability. To my mind, they've made a great product called GoGridRouter. It's an active load balancer for your Selenium nodes. With the help of GoGridRouter, you can connect to an endless amount of Selenium or Selenoid hubs or separate Selenium nodes, and you'll get a greatly scalable infrastructure for your web automation. Configuration is really simple. You need to create a quota file. Quota file is an XML in which you list browser versions and on which hosts they are available. You can also create authorization scenarios. Few users are given a certain quota based on your inner policy. There is a policy of integration with external services. You can set up the host for browser stack, for example. If you have some peculiar cross-browser testing, you can create sessions on third-party resources by listing such option in a quota file. In the closing of my speech, let's talk a bit about Docker Compose. Have someone worked with it already? Okay, cool. For some of you, it may be new information, so to say, general overview information. So what is Docker Compose for? It's a plugin or a Docker tool which allows to orchestrate the infrastructure. Simple example. On the base of Zafira QA reporting tool, we've created the simplest YAML file. In our case, Zafira is a Java-based web application which is being deployed in Tomcat. It requires access to the database. It's Postgres in our case, and we're using RabbitMQ for real-time logging. It's clear that you have to orchestrate all those components in some way, to expose the host for a Postgres container, to report it to our Zafira, and to set up the host for RabbitMQ. On the picture we can see the description of three components: DB, RabbitMQ, and Zafira. By addressing the name of the component, you can actually address the host name. While deploying this infrastructure, there is a virtual network being created, in which host names are alias to the names of the components. Docker Compose is great for creating a Selenium cluster. Right on Selenium HQ's official repository, you can see a lot of examples. Selenium itself has already released quite a lot of images for Chrome, Firefox, etc. In a few seconds, you can locally set up the hub consisting of several nodes, and with the help of Docker Compose, you can add those nodes with the help of scale operation. In closing of my report, here's a list of useful links. The first two are IroCube's GoGridRouter and Selenoid, about which I was talking earlier, and the latter three are the links to our three open source products. QPS Infra is factually a huge Docker Compose in which you can set up all the components. Zafira is a Java-based web application for reporting, and Karina is a tool connecting Selenium and Appium for automation, both mobile and web, for API testing and so on. If you have any questions left, you can ask them now or feel free to mail me and I'll try to answer as soon as possible. Yes, please. Good question, thank you. Yes, you're right. Currently, we're working on the implementation since original developers are not willing to release this code into open source for some reasons. As far as I know, EPAM has already released this feature. For this moment, with the consistent support of WebDriver agent from Facebook, guys and threads on OpenSTF described the ways to solve this problem. I think in the span of 1 or 2 months, we'll try and put this implementation for iOS also. For this moment, we don't plug the iOS devices into OpenSTF. They are registered in a general Selenium hub, but you can't do this through this web interface, through OpenSTF.
I actually have two questions. The first one, how the interface for mobile device is released in the web interface, because you've mentioned Vinci servers for web. So do you use Vinci for mobile devices or do you use something else?
You can actually see the implementation in OpenSTF. As far as I know, they use the approach with making screenshots with certain time intervals and sending it through the sockets to your web interface. So it's not a VNC as far as I get it. The process is really fast, so it looks like you're interacting with a real device. If you don't have network issues or no lags, the interaction is really smooth and the device responds quickly.
The second question is about Mac devices, about Mac Mini. You've mentioned that it's possible to connect up to 5 devices to Mac Mini, if I'm not mistaken.
Yes, it's our experience, and we didn't try to overload them. It's not always possible to find a customized assembly. i7s are quite rare now, Mac minis are mostly i5 now, so in our case, we prefer not to overload them and we connect up to 5 devices.
Is there a possibility of multi-threaded test execution on the Mac Mini and on several devices?
Yes, absolutely. It's the same as for Android devices. You run several Appium servers with different ports on one host. You run an Appium server for every device, and there is no problem with that. All Appiums are registered in a hub, and in the same way, through the proxy, tests are executed in a multi-threaded mode.
Okay, are the tools also in Docker?
No, unfortunately, they are not. At the moment, as you may know, there is no possibility to Dockerize macOS, so Dockerization is true for the Android devices. You're welcome.
I have the following question. If we discard the safety issue, did you compare the costs of your device farm against the from-the-box solutions? How much more cheap, expensive are they in comparison?
It heavily depends on the customer's requirements. One customer needs, for example, 5 devices and one server, and the other needs 30, 50 devices, and so on. There are many key details here. Aside from the cost and security, there is a need to test wearables and IoT devices. Thereafter, we can't use some third party services for this. Considering costs, you can calculate how much devices cost. If you consider this approach for a short time perspective, 2 or 3 months, for example, to set up the automation process, obviously your solution will be Browser Stack, Sauce Labs, or Amazon Device Farm. If you understand that you deploy the infrastructure to use for 1 or 2 years, it's fully expedient. I leave you my card, and here are some printed materials like booklets and stickers for everyone who's interested. You can come up and take them.
Hello. My question is, you said that everything is deployed and everyone can come up and take the device, work with it and place it back. And everything is redeployed back. But there is a great tool from Samsung and it's more secure. You have to push the button. Yes, you can trust this PC like on operation system. Did you somehow automate this or the person pushes the button?
Every our container has a single Android authorization key, and you have to apply and accept this host only once, and you wouldn't have such an alert anymore.
Okay, I got it, thanks.
You're welcome.
You've mentioned that you have Dockerization for Android. How about Dockerization for Windows 8 and 10
You're talking about Dockerization of?
mobile devices?
Unfortunately, at this moment, we're not entering this niche. I can't answer this question. Is there even Appium for Windows devices? Maybe someone had the experience with it and can give a hint? No, wait, the current question is about the automation for Windows Phone. Yes, sure. Yes, please. Maybe someone has any comments or questions? Yes, please. Can I ask to handle a microphone? It's hard to hear what's being said.
Did you experience real life situations which had showed that you really needed, for example, 30 devices?
Yes, we had such situation.
You mean you had such a situation where the error occurred on one or two devices of the whole quantity? Did you analyze it?
There could possibly be a long discussion over that topic, not even from the point of view of catching some specific bugs. How do we build a private mobile device farm for our customer? Customers have their own analytics. They work for a certain region, let's say Indonesia or South America. Thereafter, there is a specific device fragmentation in this region. For example, low performance devices. So, according to the statistics, they make a range how many people use a certain type of devices. And we try to pick the most suitable devices for this customer. The first task is, of course, conformity to those requests, and the second is available threads for multi threaded test execution. All tests are executed in parallel. If we're talking about mobile tests, it's unlike unit or API tests, they take quite a lot of time to execute. The more threads you have, the faster you can run acceptance or full regression and input the metrics into the CI.
Maybe I've missed some information from your answer. Could you please say how many tests can be run on 30 devices and what time does it take? And the data on SMAC tests and regression?
Okay, one of the examples would be acceptance testing. It is about 80 to 90 tests, regression tests, if I'm not mistaken, 350 to 400. The numbers are for our average customer. Time of execution in our case, if we take 30 threads for example, one mobile test takes 4 to 5 minutes on average. So the acceptance testing takes 10 to 15 minutes. Any other questions?
Thank you for your speech. It was very interesting to listen to. I have the following question. You use real devices and they are always on. How long do they last? How often do they break and how many devices break within the span of 1 year?
Quite a topical question, thank you. Indeed, we have such an issue with Android devices. They are constantly being plugged through USB. I've talked to the guys who fix smartphones. Battery swelling happens quite often. In our office, we have a shift schedule. Someone is always present at the office. It's convenient when we need to plug or unplug a certain device. We monitor all the devices for the swollen batteries. We change one or two batteries from 30 devices approximately once a month. Unfortunately, on some Android devices, the controller goes crazy because the device is always plugged and the battery is currently being heated to a critical temperature and the controller doesn't know what to do to recharge it or not. We've installed Xiaomi smoke sensors and also temperature sensor which allow to monitor and alarm if something goes wrong, like the battery is overheated or even if there is some smoke. We're moving in this direction, but unfortunately, there is no way to turn off the power on a device, to hold it in a standby mode for at least a few hours. I did my own research and found the vendor called Cambrionics from Great Britain. They sell controllable USB hubs. They're quite pricey. If the pluggable costs about $30 to $40, their devices cost about $600. Based on the information they provided, their products are made specifically for mobile clouds. Via API or SSH, you can send commands for turning off the power on a device. We haven't tested it yet. We'll try to get our hands on at least one device. We'll try to test it on a regular basis, like turning the power on off to keep the devices in more or less normal discharging recharging cycle. Yes, you can turn off the whole hub and don't give any power to it. Or are you talking about the smart sockets? What's the point of this? You lose the data tier and the device is out of the infrastructure. The goal is to keep data transfer running, to keep the device in the cloud but not being charged. If you have root permission on Android, you can flag the option of prohibiting the device to be charged through the USB. The whole process is kind of labor consuming and customers don't want to work with the rooted devices. You need a real firmware and devices in good condition.
Thank you for your speech. I have the following question. How much time did it take and what was the team? How many people to deploy the first infrastructure, to collect and the devices for the storage and to deploy the infrastructure with Docker and all those technologies you've mentioned?
Is this question about the time when we didn't have any experience yet?
Yes, your first experience when you had to surf the internet, to learn things, to understand what things work well together. What tools you were going to use?
I got you. We have started 3 or 4 years ago. I've had a server with 3 or 4 devices in my own closet at home. We've tried different things like installing Appium directly. This infrastructure, as it is, appeared about 2 years ago. If we were talking about the active infrastructure, QPS infra, about Dockerization, 2 or 3 persons have been putting their effort in it throughout 6 to 7 months.
Thank you. I want to ask about the internet connection on devices. Does it work well when 30 devices are connected to a single Wi-Fi spot? Are there any conflicts?
As I've said before, we've gone through such an issue. On this slide, I've mentioned that we use Unify spots in Pro version. They're actually made for commercial usage. For facilities like hotels or restaurants, they withstand high loads, and their main advantage is they let you create clusters. There is a good software for Ubuntu and Mac machines, and the device can balance the load between the spots. Now we have one provider with 150 megabit channel and two Wi-Fi spots. About 80 or 90 devices are currently connected to those spots, and we don't experience any troubles.
Good afternoon. Tell a bit about how you solve the issue when one device is blocked or updates are being installed at the moment. How do you add the devices to the cluster and remove it from there?
What do you mean by saying the device is blocked?
Device is crashing, for example, and Appium doesn't know about and starts running sessions on it and the sessions fail.
As I've said before, I didn't experience the full crash of a device before when there was nothing you could do about it. We have the web interface. Anytime you can remotely see the state of a device and acceptance alerts if there were any, even reboot the device. There is an automatic deregistration of a container. When the device is running, it also registers automatically. There's quite a lot of issues like APM fails or ADB gets timeout error. The issue is solved by simply restarting the container.
Is there any monitoring systems for this? Or you just simply restart the container after the tests fail?
Concerning monitoring, I've mentioned our product Zafira. In real time, it translates the result through the WebSocket. We see how the test starts, how it's running, the addition of some artifacts. If we see in real time there's something wrong happening on many devices simultaneously, for example, the internet connection is blocked by a provider, we can monitor that issue really fast. An email notification tool which goes through the Selenium Hub or SDF and reports how many devices are available, how many of them are busy. If the device is missing, I get email notification with all the missing devices listed in it.
Good afternoon. My question is more on the system administration side, about the infrastructure support. You've said that you have servers, UPSs, Mac minis. Who does the monitoring if there's any? For example, a common situation. There's been a power surge, UPSs went off. The server with a certain amount of devices on it didn't go up. So do you have monitoring, and if so, how is being carried out?
Good question, thank you. As I've said before, we now perform 24/7 duty. Someone's present at the office all the time. We check the batteries weekly to see if they're swollen, to be able to quickly change the faulty ones. Concerning monitoring, we use email notifications showing if the device is off. And with the help of our DevOps engineer, we're setting up Zabbix to monitor the utilization of HDD, CPU, and so on. In addition, we have the temperature and smoke sensors.
Okay, as far as I got, with the help of DevOps, you are trying to set up Zabbix,
Yes, you're absolutely right.
and with the help of it, to monitor the sensors and the hardware. Thank you. I have a question about hardware too. You said that you have 30 Android devices hanging on a single Ubuntu server.
Yes, that's what we have now.
Please answer my two questions. How did the Docker show itself in terms of stability? You actually have 30 containers running permanently on a single server. How often do fails occur? And the second question is, what are the technical characteristics of your Ubuntu server?
Thank you for your question. In our case, Ubuntu uses 4-core i7 processor. Currently, we're in the process of switching to Xeon, a newer platform with a 10-core processor. We use it for one of our customers. It has 32 gigabytes of RAM and 1 terabyte of SSD, and its key feature is having an additional PCI card with full driver support on Ubuntu. You insert the card into a PCI slot. You have 3 additional USB 3.0 connectors, and you connect pluggable USB hubs to them. From my observations, there are 1 or 2 devices per customer that fail one time in 2 or 3 days. So yes, the system is more stable than it was.
That's all. Thank you a lot.
Thank you.